When a positively charged sphere is connected to a negatively charged sphere, there is a flow of charge. Electrons will flow from the negatively charged sphere to the positively charged sphere. Flow always takes place from a higher potential to a lower potential. In the case of a ball, the natural movement is from a higher height to a lower height. In case of a U-tube, the water will flow from the higher level arm to the lower level arm until both are at the same height. So is the case with electrons, which flow from the negatively charged sphere to the positively charged sphere. When you raise the ball from the ground to a height, you end up doing some work on the ball and in the process raise the potential energy of the ball. The higher the point B, the more will be its potential energy, and the greater will be its potential to do work. Unlike charges attract each other, so in order to separate them, you will have to do some work. As you do work on B to separate it from A, you increase the potential of B. The difference in potential between A and B is known as the potential difference. The potential difference depends on the distance of separation. The ball X is raised higher than the ball Y. So the ball X will have a higher potential than the ball Y. Similarly, the charge P is separated further than charge Q from the positive charge, and hence will have a higher potential than charge Q. Potential also depends on the magnitude. Ball X is larger than ball Y. When the two balls are raised to the same height, ball X will have higher potential than ball Y. Similarly, the potential of charge P is higher since it has a higher magnitude, although the distance of separation is the same. The natural tendency of a body is to move from an area of higher potential to an area of lower potential. The battery provides the chemical energy to move the charge from a lower potential to a higher potential. The charge then has the tendency to flow through the circuit to the point of lower potential. The pump does work in pumping the water to a higher potential. The water then flows naturally to the lower potential. Similarly, the battery does work in increasing the potential of the electron, which then flows through the circuit to a point of lower potential. Current is the rate of flow of charge. You will notice that as you increase the current, more electrons will flow through the same length in the same time. Doubling the current will double the number of electrons flowing in the same time. Current is the rate of flow of charge. You will notice that as you increase the current, more electrons will flow through the same length in the same time. Doubling the current will double the number of electrons flowing. Current is the rate of flow of charge. You will notice that as you increase the current, more electrons will flow through the same length in the same time. Doubling the current will double the number of electrons. A battery takes charge of a lower potential and increases it to a higher potential. When the battery takes 1 coulomb and does work of 1 joule on it, the potential difference between the ends of the battery is said to be 1 volt. A battery takes charge of a lower potential and increases it to a... In an electric circuit, voltage is gained as the electron travels through the battery and drops as it lights up the bulb. You will notice that by increasing the voltage drop, the current increases and therefore the bulb turns brighter. By adding more cells, the voltage is increased and therefore the current is also increased, and that in turn makes the bulb brighter. You can compare the two scenarios by checking the box that says 2 cells. When you have a single bulb, the entire voltage drop occurs across the bulb, and the bulb burns bright. By increasing the number of bulbs to 2, the same voltage drop gets distributed over 2 bulbs, and the current decreases. This makes the bulbs dimmer. Resistance is the obstruction offered by the wire to the flow of current. The larger the resistance, the lower the current, and the time taken by the electron to cover the same length is much more. Resistance is the obstruction offered by the wire to the flow of current. The larger the resistance, the lower the current, and the resistance is the obstruction offered by the wire to the flow of current. The larger the resistance, the lower the current, and the time. Longer wires typically have higher resistance, since there are more obstructions over a longer path. A long garden hose will spray water with less speed than a short hose. That is because the water in the longer pipe meets with more obstructions. Wires with lower areas of cross-section will have higher resistance as compared with wires with larger areas. This is because in thinner wires, the number of collisions of the electrons will be higher, thus increasing the resistance. Ohm's law states that the current is directly proportional to the voltage. The resistance of the bulb does not change here. Notice that by increasing the voltage to 12, the current doubles and the bulb burns brighter. Ohmic conductors follow Ohm's law. As the voltage is increased, the current also increases proportionately. The graph of current versus voltage is a straight line, and the slope of the line is the current. Ohm's law states that the current is directly proportional to the voltage. In a non-ohmic conductor, the current is not proportional to the voltage. The resistance is not constant and keeps changing as the voltage changes. Superconductors have very low resistances at low temperatures. So, by changing the voltage by a small amount, the current increases substantially. The graph, current versus voltage, is very steep for a superconductor. Resistivity of a material is the resistance of a wire of that material having unit length and unit area of cross-section. Conductivity is the reciprocal of resistivity. So, the higher the resistivity, the lower the conductivity. Imagine cars from two lanes having to pay toll on one side of the lane. When the first car is paying the toll, the second car awaits its turn, and the flow of traffic slows down. If the number of lanes are increased, and you have only one toll booth to manage it, the traffic will get slower and slower. So is the case when resistances are connected in series in a circuit. The more the resistances in series, the lesser the current. Imagine having the toll booths in each lane. The cars can now pay toll in parallel. This does not create a bottleneck in the traffic. So is the case when resistances are connected in parallel. As you keep adding bulbs in series, the effective resistance increases and the current decreases. This makes the bulbs glow dimmer as the resistance keeps increasing. When a bulb is added in parallel, the first bulb glows with the same brightness. This is because it has the same voltage difference as the battery, so the current in the branch is also the same. However, the effective resistance decreases as you add a bulb in parallel. So the total current in the circuit increases as shown by the indicator bulb. The additional current now flows through the second branch of the parallel bulb. Click on the "One bulb failed" button. You will realize that in a parallel circuit, even if a bulb in one branch fails, the others will continue to glow. In a series circuit, if one bulb fails, then the others will also not glow, as the current will stop passing through the bulb that failed. A watt is the power consumed when a potential difference of 1 volt causes a current of 1 ampere to flow through the circuit. Power is measured in watts and is the product of the potential difference and the current. The terminal voltage of a cell is the work done in carrying a unit positive charge around the circuit but not including the cell. The terminal voltage of a cell is the work done in carrying a unit positive charge around the circuit. The EMF of a cell is the work done in carrying a unit positive charge around the circuit, including the cell. Since all cells contain an internal resistance, there is work done in overcoming that. So typically, the EMF of a cell will be greater than the terminal voltage. The voltage drop of a cell is the work done in carrying a unit positive charge through the cell. So, the voltage drop is the difference between the EMF and the terminal voltage. The watt is a product of the voltage and the current. In this case, the voltage remains the same. The 30-watt bulb has a higher resistance than the 60-watt bulb, and thus the circuit with the 30-watt bulb has more current than the circuit with the 60-watt bulb. Therefore, the 60-watt bulb will glow brighter. Electrical energy in a circuit is the product of the power and time. The power is a product of the voltage and current. The electrical energy is thus proportional to the time that the current flows in the circuit. Electrical energy in a circuit is the product of the power and time. The power is a product of the voltage and current. The electrical energy is thus proportional to the time that the current flows in the circuit. The heat produced in an electrical circuit is the product of the resistance and square of the current. If the current is doubled, the heat dissipated increases by a factor of 4. This is known as Joule's law of heating. The heat produced in an electrical circuit is the product of the resistance and square of the current. If the current is doubled, the heat dissipated increases by a factor of 4. This is known as Joule's law of heating. The heat produced in an electric circuit is the product of the resistance and the square of the current. If the resistance is doubled, the heat dissipated also doubles. This is known as Joule's law of heating. The heat produced in an electric circuit is the product of the resistance and the square of the current. If the resistance is doubled, the heat dissipated also doubles. This is known as Joule's law of heating. The commercial unit of electrical energy is a kilowatt hour. A 100-watt bulb is equivalent to a 0.1 kilowatt bulb. If this bulb is on for 2 hours, the energy that it consumes would be 0.1 times 2, which would be 0.2 kilowatt hour. If your water heater is rated 2 kilowatts and you use it for an hour every day, then assuming that the month has 30 days, the contribution of the water heater to your monthly electricity bill would be 240. The power produced has to be distributed a long way. There are 2 ways to transmit the power: either with high voltages and low current, or with low voltages and high current. If the high current option is chosen, the wires have to be thicker, and that increases the costs. Also, the high current option generates a huge heating loss, and heating increases with increase in current. A 60-watt bulb would consume twice as much energy as a 30-watt bulb. So, if you replaced all your 30-watt bulbs with 60-watt bulbs, your power bill would double. Imagine the two scenarios. A washing machine operating with a fuse in the circuit and another one without a fuse. If there is a sudden increase in voltage, the current in the circuit will increase. A fuse is made of a material of a low melting point. So the moment there is an excess current, the fuse will heat and melt. In the circuit with the fuse would melt and the current would stop at the fuse, thus protecting the washing machine from damage. In the circuit without the fuse, the washing machine would get damaged. When motors are switched on, they draw more current than during normal working conditions. So the current is the highest when the motor is starting. Thus, the fuse rating must be slightly higher than the starting current. When the fuse wire melts, it has to be replaced. But an MCB trips from an on to an off position. If pushed back to the on position, you're up and running. So MCBs are more convenient than fuses. Check the overload box to see the difference between an MCB and a switch. Dual control switches provide convenience in places like staircases and long corridors. Let us say you are at one end of a long corridor and want to turn off the light when you're at the other end. The dual control switch provides you the solution with a toggle switch, which you can control from either end. Click on the two dual control switches at the bottom to check how they function. Fuse wires should be made of metals with a low melting point. The melting point of copper is high, so when there is a surge in current, the fuse gets heated but does not melt. So the current continues to flow and damages the equipment. The whole purpose of the fuse is lost. Click on the box High Voltage to compare the copper fuse with a zinc alloy fuse. The fuse should always be connected at the beginning of the circuit. This way, the moment there is a surge in the current, the fuse melts and stops the current from flowing to the equipment. If the fuse is connected after the equipment, the fuse would still melt, but the current in the live wire would keep flowing to the equipment. It would be dangerous if you touched that equipment, as a current would flow through you. You can tick the box High Voltage to notice the effect. Earthing is a safety device used to prevent shocks during leakages. The earthing wire is low resistance, so a high current can flow through it. The casing is connected to the earthing pin in a 3-pin plug. If the current leaks to the casing and you happen to touch it, without earthing, you would receive a shock as all the current would pass through you. With earthing, the leaked current would pass through the earthing wire into the ground. house wiring is done as a ring main circuit. The wiring is done as a parallel circuit so that a problem with one of the appliances does not prevent the others from operating. In normal operating circumstances, the current will flow from the mains to the appliances through the live wire and from the appliance back to the mains through the neutral wire. Now, if you click on voltage leak, you will notice that the path from the appliance now goes through the earthing and not the neutral wire. The resistance of a dry body is very much higher than the resistance of a wet body. So the current which passes through a dry body is very low. But the current passing through a wet body can be very high, which increases the chance of a shock.